Okay, for number 7, again, use the limit definition to prove this. As x goes towards infinity, the root of 3x plus 1 goes towards infinity, all right? So what I'm going to do is go to the whiteboard again and write it down, number 7, all right? Put this over here, number 7. Let me sure I have the right pen out. Yep, so let's get rid of that, 7. And again, 7 reads, got to look at my notes now, it's the limit as x goes towards infinity, and it's going to be the root of 3x plus 1 equals infinity. And this is what's known as the MN definition for that limit proof. So what do? We are going to choose an M. All right, so first thing is choose. You can choose an M, and that's going to be greater than 0 then. And this is what we're saying is M is some number bigger than 0. Right, M is unbounded going to infinity, but it's bigger than 0. Then what we're going to do is, I'm sorry, I started off wrong. I said choose. I should have said given. I'm sorry about that. I'll get my eraser out. Got to keep track of this. All right, so this is going to be given. Sorry about that. So given, now we're going to choose. Sorry about that. What are we going to choose? We're going to choose an N now. Right, now I don't know what the N is. I have no idea. Right, looking at this, I don't know that. And then someone says, what are you going to do now? I'm going to suppose. What am I going to suppose? That x is actually greater than the n. All right? What do we do now? We're going to check. What are we going to check? We're going to check this over here, which is 3x plus 1. And I eventually want to get to the m in this over here. So in the end, I want an m. I don't know what that's going to be. Now look at this thing. You know, someone says, what direction? I want this thing to be huge. I want it to be bigger than something. And it's bigger than what? Well, looking at this thing, I hope you realize if I read this one down over here, that this would be true, by the way. Now someone says, how do you know that? Well, 3x plus 1, and again, x is going off to infinity, by the way, is definitely going to be bigger than 3x. If you're going off in that direction, 3x plus 1 is definitely bigger than 3x by 1, but it's still bigger, by the way. Then the next question comes is, what are you going to put down next? I want to keep going, simplifying this, by the way, and you don't have to, but I'm going to say this is bigger than the root of x. All right? Now, what allows me to do that? Well, if 3x plus 1 is greater than 3x, and I'm at this stage over here, I write this over here. Whoops, sorry about that. If I write 3x down, I'm going to say, that stands to reason, by the way, that 3x would be greater than x. Again, we're going off to infinity, by the way, so the extra positive number. So 3 times a positive number is certainly greater than that positive number itself, by the way. Now, I'm looking at this over here, and I'm going to say, well, you know what? X is greater than n, so I know this is true now. All right? If x is greater than n, I know this is true. Now, I'm at the stage where I think I can figure out what n is. How do you do that? I'm looking at this over here, square both sides, and what would n be? It would just be m squared. I'll write this over here. And we are now done. When we're done, what do? I write down QED. Now, black pen, red pen, writes down a little square box, by the way, and he shades it in and says he's done, by the way. Same meaning. Thank you.